Welcome to TechPower. Today we talk about IP address, which one of the most fundamental concepts of the internet. You have probably heard this term before. Maybe you saw it in your phone settings. Maybe someone mentioned it when talking about hacking or privacy. But do you actually know what it is and how it works? By the end of this video, you will fully understand all of these. Let's start with the most basic question. What is an IP address? IP stands for Internet Protocol, and an IP address is simply a unique address assigned to every device that connects to the internet. Think of it like your home address. When someone wants to send you a letter, they need to know exactly where you live. Without your address, the letter has no idea where to go. The internet works in exactly the same way. When your phone wants to load a website, or when someone sends you a message, the internet needs to know exactly where to send that data. And that is what your IP address is for. It is your device's address on the internet. Without an IP address, devices would have no way of finding each other, and the internet simply would not work. Now let's look at what an IP address actually looks like. A standard IP address looks something like this: 192.168.1.1. It is simply 4 numbers separated by dots. Each number can be anywhere between 0 and 255. That is it. No letters, no symbols, just 4 groups of numbers separated by dots. Every single device connected to the internet has one of these addresses: your phone, your laptop, your smart TV, your router, and even the servers that host your favorite websites. Now, here is something very interesting that most people don't know. Every IP address is actually made up of 2 separate parts: the network ID and the host ID. Let's take this IP address as an example: 192.168.1.1. The first 3 numbers, 192.168.1, is the network ID. The last number, 1, is the host ID. Think of it like a street address. Imagine you live on Green Street, house number 1. Green Street is the network ID. It identifies the neighborhood or network that all devices share. House number 5 is the host ID. It identifies your specific device within that network. Let me show you a real-life example using a home network. Imagine you have 4 devices at home: a phone, a laptop, a smart TV, and a router. Their IP addresses might look like this: your router, 192.168.1.1. Your phone, 192.168.1.2. Your laptop, 192.168.1.3. Your smart TV, 192.168.1.4. Notice how all 4 devices share the same network ID. Now let's talk about the 2 main types of IP addresses: public and private. And this is where it gets really interesting. Your private IP address is the one you saw when you went into your phone settings. It is the address your device has inside your home network. Only devices on your home network can see it. The outside internet has no idea it exists. Your public IP address is completely different. This is the address that the entire internet sees when your device connects to it. It belongs to your router and is assigned by your internet service provider, your ISP. Let me use our city analogy to make this crystal clear. Imagine a large apartment building. The building has one main address that everyone outside can see. That is your public IP address. But inside the building, each apartment has its own number. Those are the private IP addresses of each device. A stranger standing outside on the street can see the building's address, your public IP. but they have absolutely no idea which apartment you are in. Your private IP. This is an important distinction when it comes to privacy and security, which we will cover in detail in a later video. Now let's talk about something you have probably seen before, IPv4 and IPv6. The IP in both terms stands for Internet Protocol. The V simply stands for version, and the 4 and 6 tell us which version it is. So IPv4 simply means Internet Protocol version 4, and IPv6 means Internet Protocol version 6. IPv4 was created back in 1983 and became the standard that the entire Internet was built on. It uses the 4-number format we have been looking at, like 192.168.1.1. The problem with IPv4 is that it can only support around 4.3 billion unique addresses. That sounds like a lot, but with billions of smartphones, laptops, smart TVs, smartwatches, and other connected devices in the world today, we actually ran out of IPv4 addresses. So IPv6 was created in 1998 to solve this problem. IPv6 uses a completely different format. It uses both numbers and letters, and it can support a practically unlimited number of addresses, enough for every device on Earth to have its own unique address many times over. You might be wondering, what happened to versions 1, 2, 3, and 5? Versions 1, 2, and 3 were early experimental versions that never went public. Version 5 was an experimental streaming protocol that was never officially released as a standard. So version 4 became the standard the world used, and version 6 is the modern replacement we are gradually moving to today. Right now, both IPv4 and IPv6 exist side by side, and the Internet is slowly transitioning from one to the other. Now let's talk about the difference between static and dynamic IP addresses. Think of a static IP address like a permanent home address. You live there forever, and your address never changes. Anyone who wants to reach you always uses the same address. A dynamic IP address is more like a hotel room. Every time you check in, you get a different room number. Next visit, different room again. A static IP address never changes. It has to be manually configured and is more expensive to have. It is mostly used by websites, servers, and businesses that need a permanent address so people can always find them. For example, Google servers have a static IP address because if their address kept changing, nobody would be able to find Google. A dynamic IP address changes automatically every time you connect to the Internet. It is cheaper, much more common, and is used by regular home users like you and me. Most of the time, you will never even notice that your IP address changed. The system responsible for automatically assigning dynamic IP addresses is called DHCP, which stands for Dynamic Host Configuration Protocol. Think of DHCP like a receptionist at a hotel. When you arrive, the receptionist checks the available rooms and assigns you one. When you leave, that room becomes available for the next guest. Your router does exactly the same thing for devices on your home network. Now let's put everything together and understand exactly how your IP address gets assigned in different situations. When you connect to Wi-Fi at home, your phone connects to your router wirelessly. Your router's DHCP system automatically assigns your phone a private IP address, something like 192.168.1.5. Your router then connects to your ISP, which assigns your router a public IP address. So your phone has a private IP inside your home network, and your router has a public IP that the Internet sees. When you use mobile data, there is no router involved. Your phone connects directly to your mobile carrier's network tower. Your carrier acts as both the router and the ISP, assigning your phone an IP address directly. Something very interesting happens here. Mobile carriers use a technique called CGNAT, which stands for Carrier Grade Network Address Translation. In simple terms, your carrier has a limited number of public IP addresses, so they share one public IP address among many users at the same time. This means your public IP on mobile data might actually be shared with hundreds of other people simultaneously, which actually makes it harder for anyone to track you specifically on mobile data. Every time you turn your mobile data off and on, your carrier may assign you a completely different IP address, and you will never even notice. Now let's talk about what your IP address means for your privacy. When you connect to the internet, your public IP address is visible to every website you visit, every app you use, and potentially anyone who knows how to look for it. So what can someone actually do with your public IP address? They can find your approximate location, not your exact home address, but your general area, like your city or neighborhood. They can attempt a DDoS attack, flooding your IP address with massive amounts of traffic to slow down or crash your internet connection. They can try to break into your router. If your router has weak security, someone with your public IP can attempt to access your network. But your IP address alone does not reveal your exact identity or location. It only gives an approximate area. However, your ISP keeps detailed logs of which IP address was assigned to which customer and at exactly what time. So even if your IP address changes regularly, your ISP always knows who is using which IP address at any given moment. This is actually how law enforcement tracks criminals online. They obtain the IP address used during a crime, then contact the ISP to find out exactly who it was assigned to at that time. And that is everything you need to know about IP addresses. Let's do a quick recap of what we covered today. An IP address is your device's unique address on the internet, just like a home address. Every IP address has two parts: the network ID, which identifies the network, and the host ID, which identifies the specific device. There are two types of IP addresses: a private IP, which is only visible inside your network, and a public IP, which the entire internet can see. IPv4 is the original version with limited addresses, while IPv6 is the newer version with practically unlimited addresses. Static IP addresses never change and are used by websites and businesses. Dynamic IP addresses change automatically and are used by regular users like us. Your IP address gets assigned differently depending on whether you are using Wi-Fi or mobile data. And finally, your public IP address is visible to websites and potentially hackers, but your ISP always knows exactly who is behind every IP address. If you enjoyed this video, please like and subscribe to TechPower for more videos that explain how technology works in a simple and clear way. See you in the next one!